Hi students, good morning. So today let us discuss about continuity and differentiability. Continuity and differentiability. As per P board, the weightage of this topic is 20 marks. 20 marks. One mark question, the way of number of questions. 1 mark, 1 question. 2 marks, 2 questions. 3 marks, 2 questions. 5 marks, 1. 4 marks, 1, which is equal to 20. This is as per P board, the weightage of this topic is 20 marks. Okay. So to discuss this, first let us recall the first year concept limits. So which is useful here? The continuities. Before discussing continuity, first we should learn the limits. I think already you have learned limits in first year. So let us recall. Let us once again repeat that limits concept. Okay, what is limit? I think you know x tends to 2. What is the meaning of this? X tends to 2. X tends to 2 means x approaches neighborhood of 2. Neighborhood of 2, but not 2. But not 2. That means if you take the real line, there is a 2 number, here 1, here 3. Left and close to 2, left side and right side. So this part is called neighborhood of 2, but not 2. But not 2. See, first let us discuss about x tends to 2 minus. 2 minus. X tends to 2 minus means left neighborhood of 2. Left neighborhood of 2. Okay. See, left neighborhood of 2 means below 2. Below 2 and very close to 2. Means 1.9, 1.99, 1.9999. It's close to 2. For example, let this is a 2. This is I am taking 2 minus delta, where delta is very small and negligible value. If you put delta equal, for example, delta equal 0.1 if you take, what happened? 2 minus 0.1, 1.9. 1.92. So 1.9 to 2, this interval represents left neighborhood of 2. If you take delta equals 0.01, then 2 minus 0.01 is 1.9922. This is left neighborhood of 2. Okay. If you take delta equal 0.2, then 2 minus 0.2, 1.8. Then the left neighborhood is 1.822. Below 2, don't take 1 because 1 is very long. Okay, very close to 2 and left side, which is in the left side, that is called left neighborhood of 2. So it is denoted by x tends to 2 minus. Next, x tends to 2 plus, meaning is right neighborhood of 2. Right neighborhood of 2 means this side, right side, and close to 2 means 2.1. If you take delta equal 0.1, then 2 plus 0.1, 2.1. So between 2 to 2.1, each and every number, okay, that radius which is equal to the right neighborhood of 2. If you take delta equal 0.01, then the 2 open interval 2 to 2.01. This interval is right neighborhood of 2. Okay, so where delta is we don't know, but which is very small. Okay, that means right neighborhood of 2 we can write like this: open interval 2 comma 2 plus delta. Open interval 2 comma 2 plus delta, where delta is small number. So that is called right neighborhood of 2. So x tends to 2 plus means, what is the example? X equal to 2.1, 2.001. 2.012, 2.013. Those are right neighborhood of 2. Understood? Next, x tends to 2 minus means left neighborhood of 2. That we can write open interval 2 minus delta comma 2. 2 minus delta comma 2. This is called left neighborhood of 2. Left neighborhood of 2. So tell me left neighborhood of 2, one value 1.9, 1.99, 1.8, 1.99. Those belongs to this interval, that is called left neighborhood of 2. Okay, then what about x tends to 2? X tends to 2. See, x tends to 2 minus, this is 2, let this is 2 minus delta. This is this part. This is called left neighborhood of 2. Here 2, this is 2 plus delta, so this is right neighborhood of 2. Then what about this? X tends to 2. X tends to 2 means, x tends to 2 means both are there, left neighborhood and right neighborhood, but not 2. See, this is 2, here 2 minus delta, let 2 plus delta. Okay, the x tends to 2 means from 2 plus delta, open interval 2 minus delta, from here to here, but not 2. Don't take this, but not 2. Okay, so open interval 2 minus delta comma 2 plus delta except 2 is called neighborhood, related neighborhood of 2. So it is denoted by x tends to 2. So x tends to 2 means x not equal to 2. What is x equal? Maybe 1.9 to 2.1. Or if you take left side 1.8, then you take right side 2.2. Radius should be equal. Here 2 is there. So I took the distance. Radius how much here? 0.2. Right? If you take 0.2 length, then left side is same 0.2. If you take here 1.9, then this side is 2.9. But not 2. That is called related neighborhood of 2. It is denoted by x tends to 2. Are you following? X tends to 2 minus means left neighborhood. X tends to 2 plus means right neighborhood. X tends to 2 means both left and right, but not 2. Okay? See, if I take x tends to 3 minus, x tends to 3 minus, tell me the value of x tends to 3 minus. X is equal to below 3. Below 3, tell me one value. 2.9. Okay? X tends to 3 plus, above 3. 3.1. X is equal to 3.1. Here x is equal to 2.9. Just to understand that. Here nearest close to many are there. One of the numbers is 2.9. 2.9. 2.9. That is. Which is very close to 3. And here very close to 3 but right side. 3.1. 3.001. Okay, x tends to 3 means you can take from x is equal from 2.9 to 3.1, but not 3, but not 3. That is x tends to 3. Okay, now see, there is a function f of x. F of x function means every element of first set has a unique image in the second set. Okay, as x tends to a, what is the meaning of as x tends to a? Meaning is x approaches neighborhood of a but not a. As x tends to a, for example, f of x tends to L. F of x tends to L, where f of x is a function. Then L is called, here as x tends to a minus, then f of x tends to L, then L is called left hand limit. L is called left hand limit. The left hand limit which is denoted by limit x tends to a minus f of x. X tends to a minus f of x. Similarly, as x tends to a plus f of x tends to L, then L is called right hand limit. L is called right hand limit. It is denoted by limit x tends to a plus f of x. When left limit equal to right limit, LHL equal to RHL, then limit exists. Otherwise, limit does not exist. So, which is equal to limit x tends to a f of x. Tell me, what is the left limit? Limit x tends to a minus f of x. Limit x tends to a plus f of x, right limit, equal to, this is LHL, this is RHL. When both are equal, limit exists. The limit is x tends to a f of x. So here this is a function. If it is function, then we can apply limit. If there is no function, we can't apply limits. So limits is applicable only for functions. Okay, see, left limit, this is right limit, and this is limit. But here x tends to a means x not equal to a. Ready for it? Yes. Now, for example, f of x is equal to 1 when x is less than 0. When x is greater than 0, 2. F of x defined by like this. For all less than 0, 1. For all above 0, 2. So this function is changing. At what point? 0. This is called changing function. Changing function, how we know that? For example, if you draw the graph, this is 0, this is 1, this is 2, this is 2, this is minus 1, this is minus 2. Right? Right side, right neighborhood of 0. Right neighborhood of 0 value? Above 0, 2. Left neighborhood of 0 is 1. So, left neighborhood, right neighborhood is not equal. When it is not equal, this function changing at what point? 0. So, this is changing at what point? 0. See, if you take 1 at 1, tell me 1.1 comes under above 0. Next, below 1 tell me 0.9. Okay, 0.9 comes under above 0. Means left and right, both values are same. So this function is not changing at 1, at 2, at 3. But it is changing only at 0. So when it is changing, how to find limit? So if you want to find limit x tends to 0, f of x. Next, limit of x tends to 1, f of x. Limit of x tends to minus 1, f of x. There are 3 problems. How we can find? In this case, first, where we are going to find the limit? At what point? 0. At what point? 0. Okay? Check it. 0. See, let's draw the graph. Here 0, this is 1, 2, 3. Here minus 1, minus 2, 1, 2, minus 1, minus 2. First, left, x tends to 0 means left neighborhood of left limit, LHL. Limit x tends to 0 minus f of x. Below 0, tell me, below 0 comes under this. What is the function value? 1. So, left limit is 1. For all below 0, the value is 1. For minus 1 also comes under this. Minus 2 also comes under this. F of x is 1. Okay. Next, right limit, RH. Limit of x tends to 0 plus. Above 0, tell me above 0. 2. Above 0 is this 2. 0.1, 0.2. 1 comes also above 0 only. 2 also comes under above 0. So like this. See, left limit is 1. The right limit is 2. Both are not equal. Both are not equal. So both are not equal, then limit does not exist. At what point? 0. Limit does not exist. At what point? 0. So limit x tends to 0, f of x does not exist. Now, let's discuss about the second question here. Limit x tends to 1, f of x. X tends to 1, f of x. Tell me 1. If you draw the graph here, the same graph I am going to draw here. Here 0, this is 1, it's a 2, it's a minus 1, minus 2, 1, plus 2, minus 1, minus 2. Right? This is the graph. For all less than 0, this is. For all above 0, this is. At 0 not defined. Right? We are going to find limit at what point? At 1. Tell me 1 analysis. What is this? Right neighborhood of 1. Tell me this is left neighborhood of 1. Right neighborhood of 1 value 1.1. So RHN. Limit x tends to 1 plus f of x. Right neighborhood of 1 is comes under this. What is the value? 2. 2. Left neighborhood also 2. Left neighborhood of 1 0.9. 0.9 comes under above 0. 2. So both for left and right answer is same. The limit exists. Therefore the limit of x tends to 1, f of x is equal to 2. So at 2 also 2, because at 2 is not changing. At minus 1, 1 not changing. Minus 2 not changing. But at 0 changing. So this is when the function is changing. At that point we should find left limit and right limit. If it is not changing at that point, no need to find left limit and right limit. Are you following? So this is 0, 1, minus 1. At 0 changing? Yes. At 1? No. At minus 1? No. Then in both cases, no need to find left limit and right limit. In this case, compulsory we should find left and right hand limit. Okay. So when left limit equal to right limit, then limit exists. When we find left limit and right limit? When the function is changing. Let us discuss about the changing functions. This is changing at what point? 0. F of x equal one more question. 2x plus 1, x less than 1, x minus 2, x greater than 1. Tell me this function is changing at what point? At 1. Because below 1 another function, above 1 another one is there. So left to right functions are changing. At what point? 1. So this function is changing at what point? 1. What about 2? Not changing. 3? Not changing. 0? Not changing. Except this remaining points, it's not changing. Okay? If they ask limit at this point, then we should find left limit and right limit. For example, f of x equal to x when x is greater than 0. When x is less than 0,